solving the Leetcode problem 101, symmetric tree. Given the root of a binary tree, check whether it's a mirror of itself, i.e. symmetric around its center. There are two different approaches to solve this. One is the iterative way, and the other one is a recursive way. If you are interested in the recursive way, you can check out my other video. For this one, we're going to use the iterative way, which is to put into a data structure, a queue in this case, and you'll see why in a minute. So the symmetric tree, like the examples below, if it starts from the root 1 and to its left, to its right, 2 and 2, and just keep going on, and then this one returns true because it's symmetric. But if it goes only the right side and there's no left node, then we return false. So let's kind of walk through this case using a queue. Okay, so starting from the first root, we want to put the root in there. Because this is going to return a Boolean value, which is to evaluate if left equals to right, so we need two nodes basically to evaluate in each step. So in this case, the first case where we only have one root, but we can also put like 1 and 1 in here. So put the root, of course the first one equals, and once we put in a stack, then if they're equal, then we can just pop it out and keep going. We keep going to the left, so there is a 2 here, and we push 2 in here, and the right side there also is a 2, and we put this in there and pop this out. Similar thing, we keep going with the 3, and I guess I put this a little bit too symmetric. Maybe I put 4 here, and this one put 5 in here. So this one you can see when it's 3, it's symmetric, we just pop it out. But when it comes to this one, which means this 4 is the right node of this left node 2, and this 5 is the left node of this right node of 2. So we evaluate this 2, we put 4 and 5 in here. They are not equal. So these are our stopping case. If they're not equal, then we can immediately return, which means we have a base case of if the left value does not equal to the right value. Or there's also other cases where, let's say here, if you keep going to the left and right, there's nothing beneath it, or downwards or outwards, which means there are null values, then we also can return. Or there might be if there's a 5 or 6 on the left side, but there's nothing on the right side. And in this case, we can also return. So we have a left node but no right node. This means it's going to return false. And of course the other way around, we only have right but no left node. Also we can return false. So these are the base cases, and this is the data structure where we push in and we pop out. So let's call this up. First we include in and out stream. And we're gonna use a data structure, like I said, the Q in here. And for the first, we want to construct. Sorry, I can spell better. Okay, struct. Well, not sure if that's spelled correctly, but let's struct the tree node. It's gonna have a integer value, which is the value in there. Yeah, sorry, struct. And the left a value, which is going to be a pointer, and the right value, which is also a pointer. And a function where there's no value in there, so we need to set like the defaults would be 0 if there's no value in there, and the left would just be null, and right would be null too. And in the case there is a value, let's say x, then the value is x, but left, there's no left in here, and no right either. And the last case would be there is values in all three of the arguments. So the left, I need to declare the types first. It's C++, so tree node, the left, and the tree node, the right. So in this case, we're gonna put x in here, and the left node will be the left, right to be the right. Yep, I think this is about it. And let's get to the solution class and make it public. So we need a function which is going to return a boolean value of either true or false. So bool is, let's call it a symmetric, and it's gonna have one argument, which is the root, get passed in here, and we declare our Q, which is gonna be an array of nodes. Let's call it Q. And we also need to declare the left and right also to be the nodes. So tree node, left, I believe you can write like this, left and right. So the best case is, now we have this root in here. If this root itself equals to null, which means like if let's see, this one goes to the left, goes to the right, like there's no left, no right, and the root like this one or this one, there's nothing in there. In some sense it's symmetric, so we return true, of course. The other cases would be the ones we said before. If it goes to the left, in terms of this one, the left and right are no. So we don't have a left and we don't have a right. A similar thing, this should also return true because it's symmetric. Also, if only one side exists, like we mentioned here, there's 6 on the left but nothing on the right. So left or, sorry, not Python, and the root to the right. So there's only one of them. In this case, we're going to just return false. And besides this edge cases, we want to start to get, starting from the root, to push it inside our queue. So we put the queue dot push. We want to push it in the front. So we put root in there twice. So it's gonna be occupying the first spot, and also the second spot in the queue. And then we're gonna need a loop where the ending condition is this whole thing after you pop out, there's nothing left, which means it reaches to the end. Like we popped out all the things and there's nothing to be pushed into there. So while queue.empty is not true, so there's still something left. If so, we need to get to the left, which would be the ones that we, starting from the root, we pushed in. So the left one could be the queue, the front, like the first index, and then we want to pop that thing out. And similar thing, now the right goes to the front, first index, and we pop that out too. And we evaluate the if left. The value of the left does not equal to right. If that's the case, I know how to spell if. If they're not equal, then yeah, we just return false because they're not equal. We have met our edge cases, then we return false. Otherwise, we keep going, like the values are equal, then we start to go to the left side of this left side and right side of this right side. Thus, to evaluate if this two, number 3, it's a 3 there, but like to evaluate this two, if they are equal. So if first we want to make sure they exist. So if left okay, I think left to the left and right to the right. If they both exist, then we need to push, well, actually it starts from this too. First left to the left, right to right. Yeah, it's the same thing. You just keep going one node by one. From like on each node, it's left, it's right, and this one left and right. So left and right, we need to append or push. In C++ case, you push it into our queue to evaluate if the left and the right are equal. Else, if there's only one side that exists, or like over here, there's left side there's 6, but right side there's nothing. So if this is case, return false. Just to make a note here, like here the else is important, because if you compare here, it actually doesn't matter that much if you put else if here, because it's gonna return. So note here in before, it's if this thing and this thing happens, you put it in a queue, and the program is gonna keep going to the next line to evaluate. If you don't put else here, it's gonna put if this thing or this thing. Well, this or actually includes the scenarios where there's and. So even if you push it there, but then because this one also met, I mean, like if you don't have the else here, then this one or this one also means, let's say this case or this case, they both exist, and this one doesn't return immediately. This one, if you keep letting this one go, it's just gonna return false all the time, because there's or in here, and whenever it comes to this line, it's gonna return. So it will put it into the queue, but it will put even if you have the end, which their values are equal, they both exist 2 and 2, but it also, because it fits in the or condition, it's 2 and 2 also, you can see it's or, so it's gonna return here immediately, and also it means it's gonna return false all the time. Hope I've explained it. So that's why we need to put else if, like the conditions where there's just one side that exists. And similar thing to if we want to evaluate this one, 4 and 5. So 4 is the right side of this left node, and 5 is the left node is this of this right node. So if left to its right and right to its left both exist, and then we push them into the queue, and right to its left onto the queue, else if or there's only one side that exists, then we return false. And that's about it. And do doing this loop, it just keep going over this loop. And if it met any of the conditions, we return false. Otherwise, if there's nothing else left, then we return true, which means they're totally symmetric. All the values are equal on their corresponding positions. And I think that's about it. Let's put this into the main function and print it out. So we need to construct a node. Let's use the first three as an example. Test case where you have the first value 1 is the root and the left node. The second value is 2 and the third value is 2. So we want pointer value 3. Let's construct a new pointer, tree node 2, which is the third position, also at the right side. And let's put the value 2, the second value 2, because let's assume there's only these 3 nodes, so there's no left or right, so they're both null. And then the first node to the root would be your root 1, and to its left it has a point value 2 and point value 3. And just remember to delete the node, the pointers, to deallocate the space, the memory. And here the class instance, let's call it so, and we need the result to be a boolean. It's gonna come from the return value of this function is symmetric, and we pass in our root. And just to print this out, and I think this is about it, unless there's some symmetric, like some syntax or semantic errors. Okay, let's run this in the terminal. G++ q draft q, name it as okay. Standard q. Did you mean standard q? Did I put use namespace? No, sorry. Using name space standard. Is there any other identifier x? Oh, right. This one is in the lowercase. Yeah, standard. I think. Let's try it again. And we run this 1. Yes, because it is symmetric, and if I put like the third value to be 3 here, so it's not symmetric, so we're expecting false here. Compile again. 0 exactly as false. So just a quick recap. We put all the edge cases, the base case first, to put in our root. If it's null, there's nothing in there, then we can return true immediately. And also if both left and right branches are empty, return true. If there's just one side, return false. And then we push, starting from the root, we push it into the queue. And while inside of the queue, we pop out the first index value in the queue. And if the values does not equal, then we return false. If the values are equal, we keep going. We're going left to the left, this line, and right to the right. If they both exist, then push it onto the stack again. Else, if there's only one side exists, then return false immediately. And similar thing to the right side of the left and the left side of the right. Return false if only one side exists. Otherwise, if all of these conditions are met, and in the end, we return true for its symmetric. So we have the initialization, push the root here, and maintenance where it keeps going, keep pushing it onto the queue and pop it out. And the ending conditions are if the values are not equal or just one side exists, and then we return false, otherwise we return true. I hope this is helpful, and I'll link the source code down below. And thanks for watching, and see you in